So welcome to General Mathematics for the first quarter, Module 4, entitled Rational Functions. Let us discuss Lesson 1, that is Rational Functions, Equations, and Inequalities. Before we proceed, let us recall first what is a rational expression. Rational expression is an expression that can be written in the form a over b, where a and b are polynomials, and b, the denominator, cannot be equal to 0, since it will become undefined. By the way, what are polynomials? Polynomials are the algebraic expressions which consist of variables, constants, and coefficients. The word polynomial is derived from the Greek words poly means many and nominal means terms. So altogether, it is said to be many terms. Now, let's take a look on the following examples. We have here 2x squared. This is a monomial since it is only consists of one term, and that is 2x squared. Second, 3x plus 1 is a binomial since it is consists of two terms. We have 3x and we have 1. Third one, x cubed minus 6x plus 3 is a trinomial. Why? Because it is consists of three terms. First term is x cubed, second term is 6x, third term is 3. At this point of time, let's find out, let's locate where is or are the variable or variables, the constant or constants, or even the coefficient or coefficients. And to make that possible, let's take example number 3. Okay. The number 6 beside the letter x here on example number 3 is what we call coefficient. Coefficient refers to any number beside any letter or symbol in a polynomial. Next, the letters x in this polynomial is what we call the variables. Variables refers to letters or symbols in a polynomial. Lastly, the number 3 here, the integer, is what we call the constant. Constant refer to any integers, to any numbers in a polynomial. Alright. Going back, since we already know what polynomials are, let's study the following examples of rational expression. So we have here three examples. So the first one is 7 over AB. 7, the numerator, is a constant, and that is one term, and that is a monomial. The denominator AB is also a monomial. Therefore, 7 over AB is a rational expression. Second, x plus 2, the numerator, is a binomial. Its denominator, 2x minus 4, is also a binomial. And it is in a fractional form. Therefore, it is an example of a rational expression. The third one, 3x plus 5, its numerator is a binomial, and that is a polynomial. Its denominator, x squared plus 10x plus 5, is a trinomial, which is also a polynomial. And this expression is in a fractional form. Therefore, it satisfies the definition of a rational expression. Alright. When we say rational expression, it is an expression in a fractional form wherein its numerator and denominator are both polynomials, which I already discussed a while ago. So please take a look for a short period of time on the following examples. Okay. Now let's proceed to the definition of rational function, equation, and inequality. I have here a table. First, we have rational equation. Okay, So simple, it is simply an equation. When you say equation, you can see there an equal sign or an equal symbol, which contains one or more rational expressions. So tingnan natin. So we have here 2 over x, that is fractional form. So this is a rational expression, plus 6 over 2x, another rational expression, equal sign. Then 5 over 12 is a rational expression. So this is a rational equation. Next, rational inequality. By the word itself, it is an inequality that contains inequality symbols. Not only inequality symbols, but also rational expressions. Okay, here is the example. 7 all over 2x minus 3. It is an expression in a fractional form. When we say expression in a fractional form, it refers to rational expression. Okay, that is greater than or equal to 1 over x. Since there is an inequality symbol, this is a rational inequality. Last, we have, let's proceed to rational function. Okay, it is a function of the form f of x equals a of x all over b of x. Okay, we can say that it's a rational function if you can see the symbol f of x and then the equal sign. Then after the equal sign, you can see a rational expression. Okay, and there we go. Here is the example. F of x equals x squared plus 6x plus 9 all over x plus 3. Both numerator and denominator are polynomials. And that the denominator, the b of x, is not equal to 0. Okay, so that's how easy to identify whether it's a rational equation, it's a rational inequality, or even a rational function. All we need to do is to remember. Try to be vigilant, okay? To look for some clues. Okay, if you can see an equal sign, okay, connecting two or more rational expressions, and that is a rational equation. And then if you can see an inequality symbol, okay, connecting two rational expression, that is rational inequality. But if you can see f of x and equal sign, after that, there is a rational expression. Therefore, that is a rational function. Okay, so you don't have to be stressed. Okay, you don't have to worry about it. It's so easy. Okay. Now, let's move on to lesson 2, solving rational equations and inequalities. Before we proceed, let's find first the LCD of some set of polynomials. Let's assume that this one, x plus 3 and 2x minus 1, is the denominator of two rational expressions. In this case, x plus 3 and 2x minus 1 are both binomials, right? So, we just simply combine them in order to get their LCD if they are both binomials. Therefore, the LCD here is quantity x plus 3 times quantity 2x minus 1. So that's how easy. If the case is this, the denominators are both binomials. Okay, another case. I have here 2x and 5x cubed as the denominators of two rational expressions. 2x and 5x cubed are both monomials. In that case, we just simply find the LCD of their coefficients. When we say coefficients, it refers to numbers beside a letter in a polynomial. And then after that, we copy the variable. When you say variable, it refers to letters or symbols in a polynomial. And the last step is to take the exponent or to copy the exponent with the highest value. In our example, the number 2 and the number 5 is the coefficient, are the coefficients rather. And their LCD is equal to 10. Next step is we have to copy the variable x. And then we copy the exponent. The highest exponent is 3. So that's it. Therefore, 10x cubed is the LCD of 2x and 5x cubed. Okay. Now, let's proceed to another case. How about this one? I have here x squared minus 3x minus 10 and x minus 5. As you can see, the first denominator is a trinomial. The second one is a binomial. And in that case, we should have to factor first, to factor out the trinomial. When we say trinomial, it contains three terms. We have x squared, 1, 3x, 2, and 10, 3. It has three terms. Therefore, this polynomial is a trinomial. So after factoring out the trinomial, we can simply make it as the LCD. 1. Why and how? If one of its factors is the same with the other denominator. Okay, let's try this. The factor of x squared minus 3x minus 10 is quantity x minus 5 times quantity x plus 2. As observed, we have x minus 5 as one of its factors is the same with the other denominator, which is also x minus 5. And therefore, quantity x minus 5 times quantity x minus 2 is the LCD of these two polynomials above. Okay, please take a look for a while, study for a while, on how we find LCD of some set of polynomials. I think you're good. Okay, let's proceed. And now, using LCD, we try to add or subtract rational expressions. This time, I have here 3 over x plus 1 plus 4 over x minus 1. This rational expressions has unlike denominators. All we need to do is to make their denominators equal so we can add them. Okay. In this case, their denominators are both binomials. As what I have told you a while ago, if the denominators are both binomials, we just simply combine them. So the denominator, the LCD, or the new denominator would be quantity x plus 1 times quantity x minus 1. After finding out the LCD, we should have to solve for the new value of the numerator one by one. So here are the ways to find the new value for the numerator using LCD. We should have to take the LCD and divide it by the old denominator of the first expression. As you can see, x plus 1 in the numerator is the same with the denominator x plus 1. Then, we can cancel them out since that is equal to 1. And the remaining is only x minus 1. And x minus 1 should be multiplied to the numerator 3. And that can also be written as 3 quantity x minus 1. 3 quantity x minus 1. So we are not yet done here. All we need to do is to distribute 3 on each term inside the parenthesis. So that is 3 times x and 3 times negative 1. And it will give us the result, which is 3x minus 3. And then we should have to write this on the numerator above. Okay, now let's proceed on finding out the numerator, the new numerator of the second expression, 4 over x minus 1. Same process, copy the LCD, then divide it by the old denominator. And in this case, as you can see, we have x minus 1 on the numerator. We also have x minus 1 on the denominator. They are just the same. Okay, so we can cancel them out, which is why? Because they're just equal to 1. And the remaining is quantity x plus 1. We should have to multiply that to the old numerator, which is 4. And that is also be written as 4 quantity x plus 1. Same process above. We must have to distribute 4 on each term. That is 4 times x and 4 times 1. And it will give us a result which is equal to 4x plus 4. And then write this on the numerator above. Copy plus and then combine this one. Okay, that's it. So, as you can see, we have now the new numerator, but it is still simplifiable. We should have to combine them first. we should have to combine the like terms. We have 3x and 4x. They're both positive, so we have to add them. 3x plus 4x, that is 7x. We also have negative 3 and positive 4. They're unlike sign numbers, so we must have to subtract them. 4 minus 3, that is 1, and copy the sign of the larger number, which is 4, that is positive. So negative 3 plus 4 is positive 1. The result would be 7x plus 1 all over quantity x plus 1 times quantity x minus 1. That is now our final answer. Okay, that's it. Now, let's proceed on solving rational equation. I have here, guys, an example, which is x over 6 plus x over 12 is equal to 1. So, the first step is to find the LCD and multiply it on the whole equation to eliminate the denominator. So, we must have to eliminate the denominator so we can solve for the value of x. So, let's copy it first. Okay, the denominators are 6 and 12, and their LCD is 12, right? So we must have to multiply the whole equation by the LCD, which is equal to 12, and it will give us, and then multiply 12 on both terms, so that this will give us 12x over 6 plus 12x over 12 is equal to 12 times 1, that is 12. After that, we must have to simplify them. 12 over 6 is simplifiable. We must have to divide them. 12 divided by 6, it will give us 2. And the other one, 12x divided by 12, that is 1. 12 divided by 12 is 1. So 1 times x, that is x. So it will give us 2x plus x is equal to 12. Okay, we're not yet done here. We have 2x plus x. They are like terms, so we must have to add them. 2x plus x is 3. So it will give us 3x equals 12. And now, to finally solve for the value of x, we must divide both sides by the number. What number? The number beside the variable x, which is 3. So we must have to divide both sides by 3 to eliminate this one. To solve for x rather. So we have 3x over 3, 3 over 3, 3 divided by 3 is 1. So it will give us x na lang. And then 12 divided by 3, that is equal to 4. Okay. So the answer is x is equal to 4. That is now the value of x. In order for us to check whether our answer is correct, we must substitute the value of x to the equation. So let's have some checking. Okay, copy the original rational equation and then substitute the value of x, which is 4. It will give us 4 over 6 plus 4 over 12 equals 1. And then simplify them. 4 over 6 is simplifiable. Its lowest term is 2/3. 4 over 12. When we divide it by 4, 4 divided by 4 is 1. 12 divided by 4 is 3. It will give us 1/3. That is 2/3 plus 1/3 equals 1. In this case, we have two fractions with the same denominator. So we can add them. So just simply add the numerator, 2 plus 1, 3, then copy the denominator. That is 3 over 3 equals 1. And 3 over 3, that is equal to 1. And our answer is correct. Why? Because 1 is equal to 1. Therefore, 4 is the solution of the rational equation that we have here above. Okay, that's the whole process on solving rational equation. Now, I will give you another example. I have here a problem. Solve for x. Okay, here is the equation. 3 over x minus 5 is equal to 4 over x plus 5. Okay, so let's copy that one. Okay. Both denominators rather, are binomials. So the first thing to do is to find their LCD, right? So, on the LCD here is quantity x minus 5 times quantity x plus 5. We must have to multiply the LCD on the whole equation. Okay. The LCD multiplied on the left expression, x minus 5 here can be cancelled out, and the remaining is x plus 5. So, it will give us 3 times quantity x plus 5 on the left side, then copy equal sign. And then on the right side, when we multiply that, we have to cancel out x plus 5 on the denominator and x plus 5 on the numerator, since that is equal to 1. And the remaining is for quantity x minus 5. So here we go. Then after that, we must have to distribute. Here we have to 3 times x will give us 3x. 3 times 5 will give us 15. On the right side, 4 times x will give us 4x. 4 times negative 5 will give us negative 20. That's it. Okay, we just distribute. We multiply 3 on each term inside the parentheses. Here on the left side. On the right side, we multiply 4 on each term inside the parentheses. 4 times x, 4x, 4 times negative 5, negative 20. After this one, we have to combine the like terms. So I want to write all the variables, all the terms with the x variable on the left side. So I will transfer 4x on the left side. From positive, it will become negative. Then 15 here, I'll transfer this on the right side. From plus 15, it will be negative 15 or minus 15. So this is the result when we transfer. Okay, from positive 4x, it becomes negative 4x. From plus 15, it becomes minus 15. And then we simplify. 3x minus 4x, that is negative x. Why negative x? Because the subtrahend is less than. Okay, as compared to the minuend. Okay, so this is negative x. And then on the right side, negative 20 minus 15, that is negative 35. You can use your calculator in solving this kind of problems. Okay, okay, we have here negative x is equal to negative 35. So I just want to eliminate the negative sign on the variable x. So what are we going to have to do? So all we need to do is to multiply both sides or the whole equation by negative 1. And the result is x equals 35. That is now the value of x. So let's have the checking. Okay, copy the given equation and then substitute 35 on each x variable. So we have 3 over 35 minus 5 equals 4 all over 35 plus 5. And then let's simplify them. Okay, copy 3 all over 35 minus 5, that is 30. And then copy 4 all over 35 plus 5, that is 40. And then we can still simplify these expressions into their lowest terms. So 3 over 30 can be divided by 3. So 3 divided by 3 is 1. 30 divided by 3 is 10. It will give us 1 over 10. And on the right side, 4 over 40 is divisible by 4. 4 divided by 4 is 1. 40 divided by 4 is 10. 1 over 10 is equal to 1 over 10. Therefore, our answer is correct. So, we must say that 35 is the solution on the equation we have above. And now, I have here another method. So, aside from multiplying the LCD on the whole equation, we can also do some cross multiplication, just like this. Okay, must have to multiply x minus 5 times 4 and x plus 5 times 3. So that's it. You have 3 times x plus 5 equals 4 times x minus 5. And then, after that, we have to distribute. As you can see, they have the same process. Okay, we have 3x plus 15 equals 4x minus 20. And then combining like terms, transfer 4x on the left side, transfer plus 15 on the right side. It will give us 3x minus 4x equals negative 20 minus 15. And then simplify 3x minus 4x, that is negative x. Negative 20 minus 15, negative 35. Eliminate the negative sign by multiplying negative 1 it will give us x is equal to 35. So all we can say that it has the same solution and result as to our first method on the left. Okay, it depends on you on what method are you gonna have to follow. Okay, that's the whole process on solving rational equation. Okay, kindly take a look for a few seconds. Okay, I think you're done. Let's move on. Now let's proceed to solving rational inequality. So I have here solve 9 over x minus 3 greater than 3. Okay, the first step is express the left side of the inequality, this one, into one fraction and let the right side be 0. So it must be 0. So what are we going to have to do? So we should have to transfer 3 on the left side. So from positive 3, it will become negative 3. So this will become 9 over x minus 3 minus 3 is greater than 0. Then after that, we should have to combine the terms on the left side of the equality by using the LCD, which is x minus 3. This is the LCD. Okay. So after doing this, the result is this one. 9 minus 3, quantity x minus 3 all over x minus 3 is greater than 0. Okay, this time we must have to distribute 3 on each term inside the parenthesis. Okay, that will give us 9 minus, okay, we have here negative 3 times x, negative 3x. Negative 3 times negative 3 will give us positive 9. All over x minus 3 is greater than 0. Okay, this time, we have like terms, so we must have to combine them. 9 plus 9, or we must have to simplify. 9 plus 9, it will give us 18. So the result is negative 3x plus 18 all over x minus 3 is greater than 0. So this is now what we call the general form of a rational inequality. Okay, in this case, if the right side of the inequality is 0, we can now solve for the rational inequality. So the next step, second step, is to equate both numerator, this one, to 0, and the denominator to 0 as well, and solve for x to get the critical values. Okay. The numerator, we have negative 3x plus 18 equal to 0. Solve for x, we must have to transfer 18 to the other side. It will give us negative 3x equals negative 18. Solving for x, we must have to divide both sides by negative 3. Why negative 3? Because that is the number beside the variable x. And then negative 3 divided by negative 3, that is positive 1. Right? Negative 18 divided by negative 3 is positive 6. So x is equal to 6. Now let's proceed on the denominator. We have x minus 3 equals 0. Then solve for x. We must have to transfer negative 3 on the other side of the equation. So this will become x is equal to positive 3. Therefore, x equals 6 rather, so sorry for that, and x is equal to 3 are the critical values. After knowing the critical values, we should have to test these critical values, whether they're a solution or not. Okay, so how are we going to do that? Okay, at x equals 6 muna tayo. Okay, so we should have to use what? Is this one or this one? Okay, let's see. We should have to use the first given inequality. Okay. So we have here 9 over 6 minus 3 is greater than 3. Okay, simplify. 6 minus 3, that is 3. 9 over 3 is greater than 3. 9 divided by 3 is 3. Is 3 greater than 3? No, because that is equal. So this is false. Therefore, it is not a solution. Okay, now let's proceed on x equals 3. At x equals 3, we have 9 all over 3 minus 3 greater than 3. Okay, 9 all over 3 minus 3, that is 0. So 9 over 0 greater than 3. So 9 divided by 0, of course, that is undefined. We cannot divide any number by 0. So therefore, this one is also a false. It's not a solution to our rational inequality above. Okay. It's not a solution. Okay, next step. Let's proceed to the third step. Okay, the third step is to break the number line into intervals by plotting the critical values on it. Okay, we have here the number line. Okay, I have here 3 and 6. So the critical values are 3 and 6. So we make now an interval. We have in between 3 and 6, that is point B. Before 3, that is point A. After 6, that is point C. So after breaking them into a number line, after breaking the number line into intervals, the next step is to construct a table of signs by using the intervals on the number line and select one x value as test point for each. So we must have to select one value for point A, point B, and point C. So here is the table. The interval is like this. Point A, that is x is less than 3 since that is before number 3. And then for point B, that is in between 3 and 6, the interval must be like this. It can be read as x is greater than 3 but less than 6. X is greater than 3 but less than 6. On point C, the interval must be x is greater than 6 because point C is after the number 6. And then we select the test point or value for point A, B, and C. So for A, I chose x equals 2. This is the nearest value before 3. And for point B, I chose x equals 4. For point C, I chose x equals 7. Okay, so what is the next thing we need to do? We have to substitute the value of x on each expression here on the left side. So we separately write the numerator, the denominator, and of course the whole expression. So as you can see, guys, I use the expression which has 0 on the right side. Okay, this is negative 3x plus 18 all over x minus 3 is the standard. This is the standard. Okay, it is the rational inequality which has 0 on the right side. Okay, so always remember we should have to use the rational inequality which has 0 on the right side, or the inequality in its general form. Okay, so x equals 2. So I must have to put here the solution here above. When we substitute 2 on negative 3x plus 18, the answer is positive 12. So we must have to put here the sign. What is the sign? That is positive. Next, at x equals 2, okay, substituting to x minus 3, we have here negative 1. The sign is negative. So that is negative. And now, when we combine the two, this one divided by this one, that is positive divided by negative, the answer is negative. Now let's proceed. At x equals 4, okay, solving this one, negative 3x plus 18, when x equals 4, it will give us positive 6. So the sign here must be positive. And then at x equals 4, solving x minus 3, we have positive 1. So the symbol here is also positive. And then when we divide this one, positive divided by positive, it will give us positive. A positive sign. Now, let's proceed on the fourth column. Okay, at x equals 7, solving negative 3x plus 18 at x equals 7, we have negative 3. So the sign here is negative. And then at x equals 7, solving for x minus 3, it will give us positive 4. So the sign here must be positive. Then dividing the two, negative divided by positive, the answer is negative. Okay, this time, okay, this is the general form of the inequality, of the rational inequality. Since negative 3x plus 18 divided by x minus 3 greater than 0 calls for positive results. Why positive results? Because greater than 0, right? All numbers greater than 0 are rather positive. Okay, so we shall take the interval, this one, x greater than 3 but less than 6. Why? Because the result sign is positive. It is positive. And then, the solution set must be like this. This is how we're going to write the solution set. So, how are we going to read this one? Okay, okay, follow me. Listen carefully. This is how are we going to read this solution set. X is an element of all real numbers such that x is less than 3, but x is greater than 3 rather, but less than 6. Okay, I will repeat. X is an element of all real numbers such that x is greater than 3, but less than 6. Okay, this is now the solution set. Okay, another thing. So, sir, what if the critical values we have a while ago is a solution set? So, what if 3 is a solution set in our rational inequality? So, how are we going to write or to express our solution set? So, this is how are we going to express that? Okay, just like this. Just add the equal sign. So, we have here x is an element of all real numbers such that x is greater than or equal to 3 but less than 6. Okay, when 3 is a solution. So, sir, what if 6 is the solution and not 3? So, this is how are we going to express that? X is an element of all real numbers such that x is greater than 3 but less than or equal to 6. As easy as that. So you don't have to worry about. Don't be stressed. Okay? So take a look first, take a study, okay, on how we solve for rational inequality. So I hope you learn something from this. It helps a lot for you on how to solve rational equations and rational inequality. So that would be all, and thank you for listening.